All right, folks, everybody's eyeballs up here. Please, please, please look at this problem. Last period, I discovered a kid who was finding vertex by looking on the screen of her calculator and trying to count where the vertex is. You find the vertex mathematically, okay? But on this picture, it's different because I have a nice big grid, and your vertex I'm going to mark for you with a nice big dot. It's definitely at a nice whole number. So sometimes, yes, you can get the vertex from a picture. Not normally, though, and certainly not from the picture on your calculator. You could get a good estimate, but you certainly couldn't get the 100% accurate vertex. There is a way to mathematically do that if you know an equation. But on this one, I didn't give you an equation, did I? I just gave you a picture, and yes, I made the vertex a nice, easy, whole number. What I want to show you first is how vertex relates to range and how it relates to the axis of symmetry, because I saw weird answers on your quiz. So everybody should be able to look up here and count out the vertex. Can you normally do that? No, normally you got to mathematically figure it out. What is the vertex, though? 2, 4. Are y'all with me? Please, please, please make sure you're listening. Don't make the mistakes I have seen. I had somebody in second period tell me the vertex was 2. What did they do? They gave me the x and not the y. If I want a vertex, I am asking you for a point. That means an x number and a y number. Now, if you know the vertex and you can see a picture of it, then you'll be able to answer the axis of symmetry and the range. So please look up here and let's talk about how those two things relate. Axis of symmetry. I feel like some of you still don't even know what I'm asking for. Axis of symmetry, what is it? It is a vertical line that goes right through the vertex, right through the middle of the graph. It cuts it exactly in half. Okay, and it is related to the x value of the vertex. But this is what I had some people tell me when I asked for axis of symmetry. They told me 2. It's x equals 2. And if you just put a 2, Haley, this is the part you need to be paying attention to. If you just put a 2, I will not give you credit. And I had some kids tell me the axis of symmetry was 4, which that's about as wrong as you can get. So do not just tell me 2. It is the equation of a vertical line. So you better have the x equals part or I will not give you credit. It's the vertical line that goes through that point, and every x value on that vertical line is 2. That's why the equation of the line is x equals 2. So can you just tell me 2? No. All right, range. Domain. Domain is super easy. And yes, you're going to have some of these for homework, and all the answers are going to be super easy. If you're looking at a parabola, a whole full parabola with the arrows, domain of any parabola is what? All real numbers. That's because it goes on forever to the left and right. Domain is the left and right edge. And if you see arrows on the left and right, that means it never ends to the left and it never ends to the right. And it doesn't matter how skinny it is. It doesn't matter how fat it is. If you've got those arrows, domain is all real numbers. And that's if you have a picture or an equation. Domain of a regular parabola is all real numbers. The only exception will be if we're not talking about the whole parabola. Like if we're just looking at the first quadrant, which we will do that. That's what we were going to do today. But otherwise, if it's a parabola, domain is all real numbers. Here's where I still am losing kids. Range. Range of any function is the y values. Okay? Now, on a parabola, it doesn't go on forever to the top and the bottom. Range, again, is the top and the bottom of a picture. Well, this goes on forever to the bottom, but it definitely has a highest point. It has a top point. Right? So if you are asked to find range, you have to know what the vertex is. Now, I asked for range on the quiz, and some kids told me 2, 4. Is that a range? No, that's a what? That's a point. In this case, it's the vertex. I had some kids tell me the range was 4. I mean, that's a possible range, but that means the only y value on the whole picture is a 4, and that's not true. There's millions of y values on this picture. It doesn't look like it. All right, the range is the y values. Now we have a highest y value, which is 4. But that's not the only y value. There's millions of y values on this picture. They are all less than or equal to 4. Because it's a frown. What if this had been a smile and the vertex was at 2, 4? Then it would have been greater than or equal to 4. Okay, so to find range, you must know what the vertex is. Specifically, you must know the y value of the vertex, and it's either going to be all the numbers are below that or all the y values are above it if you've got a smile. Okay, zeros. What in the world am I asking you to find if I want the zeros? The roots, otherwise known as what? X-intercepts. That's where it crosses the x-axis. Sometimes if I give you a nice clear picture with nice whole number roots, then you can just look at the picture. Normally you've got to find it mathematically. How would I find it if I didn't have a picture? If all I had was an equation? You would put the equation in, and then you would also put in what? Y equals 0. That's this line right here. And you would see where they intersect. So what are the zeros of this picture? -1 and 5. Those are the zeros. If you wrote them as points, it would be -1, 0, 5, 0. If you wrote them as set notation, it would be -1, 5. Please don't write it like this. Why not? Yeah, they don't make a point together. They make two different points with a y value of 0. All right, now, here is where I'm still getting mistakes as well. Where does this function equal to? I am giving you a y value. Shayla, are you with me? Where does this function equal to? Look up here and tell me if you can find out where this function equals to. I need numbers. 0 and 4. When I give you f of x equals 2, that's like telling you y is 2. Y is 2 anywhere on this line right here. That's here and here. It's kind of like finding the zeros, except we're not finding the zeros, we're finding the 2's. Look at this point right here. It's 0, 2. And this point right here is 4, 2. So where does this function equal to? At 0 and 4. Okay, now that's from a picture. Let's go through some. This is like what we did yesterday. You should be able to do all of these things with a function rule. I didn't give you a picture this time, I gave you the function rule. I want you to find vertex, axis of symmetry, roots, domain, and range. I want you to find when f of x equals -3, and I want you to find f of -7.2. I'm going to pause while you guys work on all those things. This is everything you should know how to do with a quadratic function as of right now. How in the world do you find vertex? Yeah, it's not just looking at it and counting, especially when all you have is a calculator picture. So let's put this in and look at it just for fun. Well, we're going to need it in there anyway. Y equals -x squared plus 3x plus 10. I can't even see the vertex on my calculator screen because it goes above 10 on the y-axis. So there's no way you can just count out the vertex. You've got to do some math. How do you do the math? It's the opposite of b over 2a. That's for part of the vertex. That's the x part. You have to then turn to your calculator to find the y that goes with it. That's why I call this way half brain, half calculator. I'm going to show you how to do it all in the calculator in just a second. Okay, so the opposite of b over 2a. This part you have to know. This is your brain part. To find the x value of the vertex, it's the opposite of b, which would be -3, over 2 times a, which would be 2 times -1. And what's -3 over -2 going to reduce to? +1.5. Okay, so that's the part I did with my brain. Now, if I didn't have a calculator, look how yucky this is. I would have to do 1.5 squared times negative 1 plus 3 times 1.5 plus 10. We're plugging in 1.5 for x, but we're going to make the calculator do that for us. Where can I find the y that goes with that? In the table set, in the table of values. But first I'm going to tell the table to start at 1.5. I'm going to go to the table set key, which is above the window key. And I can control the x's. Okay, so I know that the x is 1.5, so I'm going to make the table show me an x value of 1.5. What's the y value that goes with it? 12.25. So there's my complete vertex, the x number and the y number. Here's another thing you could do when you know an x. And I do want y'all to look up here. I want you to be comfortable with this way too. If you know an x value, you can do calculate. Remember, calculate and trace are the same key. And you can do calculate value. That's anytime you know an x. And it's going to ask you, the blinker is saying, what do you want x to be? What do you know that x is? Well, I know x is 1.5. Hit enter and it tells you the y that goes with it. So that's just another way. If you know the x, you have two ways to find the y that goes with it. T-chart way, where you tell the table to start wherever you want it to start, and then you look at the table of values. Or do second function and then hit the trace key, which means calculate, and we're going to calculate a specific x value. And it's going to ask you, what is x? That's when you know the x, and the calculator finds the y. Okay, now, once I know vertex, it helps me do a whole bunch of other stuff. First of all, it tells me axis of symmetry right away. What is the axis of symmetry? Do not just tell me 1.5. X equals 1.5. That is the vertical line at 1.5. It goes right through the whole middle of the graph. Roots. That's where this thing crosses the x-axis. That's where the y value equals 0. That's why roots are sometimes called zeros. I think they were nice whole numbers, weren't they? Calculate intersection. Now remember, this only works if you also put in y equals 0. Some kids forget that. They know they're finding zeros. They've got the function rule in there, and they do calculate intersection. First curve, second curve, and then it never stops getting off the second curve screen. Why? What's it trying to tell me? You're missing the second curve, the second equation. You have to remember to put in y equals 0 if you're going to do it this way. Then I can calculate intersection. It's always going to ask you that first curve, second curve, and then guess. Please don't stop till you see the word intersection. And you should see what the x is and look what the y is. 0, because that's what we're finding, the zeros. So one of the zeros, or one of the roots, or one of the x-intercepts was negative 2. How do I find the one that's way over here? Trace. Please do not use trace key. Some kids are doing this. They're using the trace key and like hovering over where they think the root is and writing down what they see here. Trace is not accurate. Trace helps me move my cursor around. So don't use trace key for calculating anything. Just use it to move. So we're going to calculate intersection. First curve, second curve, guess. And there's my intersection. Says intersection, and it has the point right there for me, 5, 0. So what's the other root? 5. So 2 and 5 are my roots. What's the domain of any parabola? All real numbers. Yeah, now that's any parabola that's got arrows. If I just give you an equation, that's the whole parabola. That means the left and right go on forever. Now, range is never going to be all real numbers for a parabola. And it's not going to be one of those things where it's in between two values either. It's going to be, it's going to have a top or a bottom. Look at this picture. Do we have a top or a bottom? We have a top. Range is related to the vertex. Specifically, what part of the vertex? The y value. We already found the y value of the vertex, 12.25. That means that's my highest y value on this whole picture. It's not going to go any higher than 12.5 on the y-axis. All the other y values on this picture are what? They're under it, which means less than or equal to it. So that's how I would describe the range. It's related to the vertex. Is it the vertex? No. If I ask you for range, don't tell me 1.5, 12.25. That's not a range. That's a point. All right, now, look at these last two. Here, you've got to know what I'm giving you and what I'm asking of you. What I'm giving you here is an x value on this problem right here. F of x equals negative, oh, I'm sorry, that's not, I did it backwards. What am I giving you right here? A y value. How do I know that's a y value? Right, it says f of x. What does f of x mean? Y. So I want to know, where does this function have a y value of negative 3? Where do I go when I know the y value? Yeah, I go to y equals. I cannot control the y's. I can only control the x's. The problem is I don't know the x. I'm trying to find the x. I know the y. The only thing I can do when I know the y is go to y equals. Instead of putting y equals 0, we're going to put in y equals negative 3. We're not finding the zeros now. We're finding the negative 3's. And it's going to draw a vertical line across the axis, across the picture at negative 3. Okay, so we're looking for this point and this point. It's just like finding zeros, except we're finding negative 3's. I'm going to calculate where they intersect. First curve, second curve, guess. And sure enough, look at this weird x value it gives me, but what's the y value? Negative 3. How many places did I tell you to write down for me? 3. So you're going to write down negative 2.405. That's one of the places where this function equals negative 3. At negative 2.405. How do I find the other one? Hit trace. Scroll over there to the other side and do it again. Okay, as long as I'm closer to the other one, now I can do it again. Calculate intersection, first curve, second curve, guess. And look, there's the y value of negative 3, and there's my weird x value that makes that happen. 5.405. Now, look at the last question. What am I giving you on this last question? I'm giving you an x value. I want you to find this function when x is negative 7.2. When you know the x, your life is easier. Where do I go to control my x's? Table set. Or calculate value. I could just go straight to calculate value, and it's going to ask me, what do you want x to be? Or what do you know x is? I know x is negative 7.2. Hit enter, and what's the y that goes with it? Negative 63.44. Or I could have done it in the t-chart. I could tell the t-chart to start at negative 7.2. Look at my table of values, and sure enough, negative 63.44. Okay. Look at this problem. I'm thinking of a parabola. It's got a vertex of 4, negative 5. And it is a smile. What's the range? Y is greater than or equal to negative 5. If I know that the vertex is at positive 4, negative 5, and I told you it was a smile, well, that's not very pretty, is it? That means this is the lowest y value I'm ever going to have, this right here, and all the other y values are higher than it or greater than it. What's the axis of symmetry of this function? X equals 4. Are we good with that? All right, you try these problems, please. Check answers with someone around you when you are done. I'm going to pause while you work them out. All right, let's go over these, and then I'm going to show you a different way to find vertex. What is the vertex? 2, 6. Can you get that just by counting on your calculator? No. You have got to do the opposite of b over 2a, and then you look at your t-chart to find the y that goes with it. Are we okay with 2, 6 as the vertex? All right, what's the axis of symmetry then? X equals 2. Question? No. I mean, you need to know if it's a minimum or a maximum when you find range and things like that, but I'm not going to make you write it. Is it a minimum or a maximum? This is a maximum, yes. All right, domain. What's the domain of all parabolas if they go on forever? All real numbers. Range is related to the vertex, specifically the y value. But if you just put 6, I'm going to count it wrong. In this particular problem, it's anything less than or equal to 6 because this was a frown. So 2, 6 was at the very top of the picture. That means all the y values are 6 or smaller. Roots. Were they nice whole numbers? What were the roots? Yes, and I would write that in set notation. You don't want to write it like a point because they don't make a point together. They make two separate points. All right, what was f of negative 7.5? I gave you an x. You found the y. On the last one, though, I'm giving you a y, and you find the x. Or in this case, x's. There's two of them. What were they? 0.267? 3.732. Okay, let's see. Let's do this. If you didn't get what we just called out, let's try this. Negative x squared plus 4x plus 2. Okay, so you're talking about the last one where I asked you where f of x equals 3. I'm just going to look at a picture of it. Oh, I did. Whoopsie. We want to know where this function has a y value of 3. It's going to put that vertical line across it at 3. It's happening twice, right here and right here. Please make sure you don't stop till you see the word intersection. Some kids accidentally stop when it's still asking you to make a guess. Second function, calculate intersection. First curve, second curve, guess. Make sure you see the word intersection, and you should see a y value of 3. And there's the x value, 2.67, and then I said you could drop it off after 3 places. And then hit trace, go over to the other side. And again, you want to look for that word intersection. Calculate intersection. First curve, second curve, guess. You should see the word intersection here. You should see a y value of 3. And there's that weird x value that makes it happen, 3.732. All right, are we feeling better about these? Now, one thing I want to show you, and I need you to look up here. I want to show you how you can find vertex with the calculator. But let me just tell you, the reason why I didn't show you this in the first place is because it gives you weird x values. It gives you a very perfectly correct y value, but it gives you some weird x values. They're very, very close to the correct answer, but it's usually just a little bit off. Shayla, sit up, please. So, you also have to know whether it's a minimum or a maximum to do this. We've already got the equation in there. Whoopsie. Shayla, up, up, up. Okay, so here is our function. Y equals negative x squared plus 4x plus 2. If you look at the calculate key, everybody go to calculate with me. What's one of the things it can calculate for us? The minimum or the maximum. That's another way to say vertex, but you have to know whether it's a minimum or a maximum. And in this picture, what is it? It's a maximum. So I'm going to do second function, calculate maximum. Now, it's going to ask you for some boundary numbers. It wants to put arrows around the vertex. Do you see where it says left boundary? You can either enter a number that you know is to the left of this vertex, or just look at your cursor. Make sure your cursor is to the left of the vertex. Is it to the left? Then hit enter. And do you see how an arrow pops up? Then it's asking me for a right boundary. Well, my cursor is not to the right of the vertex right now. How can I make it go to the right? You can just hit the arrow key. And now, once I'm safely to the right of the vertex, I hit enter. It always asks for a guess. Ignore that and hit enter. Now look what it tells you the maximum is. It says 2.0000011. And one time when I did it, it said 1.9999999. It's neither one of those. It's exactly what? It's exactly 2. The y value is correct. Remember, we did this mathematically a second ago and got 2.6. But what you can get is a real quick estimate of the x value and a perfect y value. And some kids can look at this and go, oh, I know it's supposed to be 2. But I just don't want you to put 2.00000011. That's not it's not correct. The exact x value is always found by the opposite of b over 2 times a. It's not 2 point anything. It's exactly 2. Okay, so that's the only reason I really didn't show you that way in the beginning, because it gives you weird x values. Is the y value correct? Yes. Let's try another one with the calculator. Let's look at, what was the first one we did? This one. Put that rule, everybody, into your calculator. Y equals negative x squared plus 3x plus 10. Let's just look at a picture of it real quick. This is a frown. So if I want to get the calculator to find the vertex for me, am I looking for a minimum or a maximum? So I'm going to do second function, calculate maximum, which is number 4. It's going to ask for a left boundary. All I need to do is make sure my cursor is somewhere to the left and hit enter, and an arrow pops up. Then it wants a right boundary. Now I've got to move my cursor till it's safely over to the right and hit enter, and then an arrow pops up. Make sure your vertex is in between those arrows. Then it says guess, hit enter until you see the word maximum. Guess what the x value really is supposed to be. It's exactly 1.5. It's not 1.50008. It's not 1.4999999. It's exactly 1.5. This is what I would do. I don't mind you looking at that. It's definitely accurate on the y value. And I think the little flat yellow calculators are a little bit more accurate on the x value. But what I would do is double check yourself on the x. The opposite of b over 2 times a. It only takes a second to do that. That's 3 over 2, which is exactly 1.5, 1.5. It's not 1.49999. It's not 2. Somebody wanted to round it up to 2. It's certainly not 2. Okay, so that's the only reason I hesitated here. But the y value is perfectly accurate. It's just the x value, they give you weird x values. What always works for x value? Opposite of b over 2a. Does it give you a close x value? Absolutely, but it's usually not perfect. All right, we are going to go over your quiz, and then I'm going to show you your homework. For homework, what we are going to do is problems just like what we've done here. I'm only giving you 3 problems. Doesn't that sound good? But for these 3 problems, you have to find 7 things. You need to list the vertex, the roots, the axis of symmetry, the domain, the range. Find f of negative 4.3 for all of them. Find where f of x equals 2 for all of them. Now, but look at number 4. What's number 4 going to be for all of these parabolas? All real numbers. So really it's only 6 questions. And they can all be done in the calculator. Sure. Jair just asked if he could label these A, B, C, D, E, F, G. That's fine too. He likes letters better than numbers. And Chris knows his alphabet. Look at that. Ooh, Mackenzie can count to 7. Even more impressive.